Most people eat fish without knowing the secret hidden in its scales. What if I told you that these tiny rings you see on a fish scale can tell us the exact age of the fish and even reveal whether an entire fish stock is thriving or collapsing? Yes, just like the rings in a tree, fish carry their life history written on their bodies. Scientists use this simple but powerful method to make big decisions about fishing, conservation, and food security. In this video, I'll show you how scientists determine the age of fish using rings, also known as annuli, and how this information is used in stock assessment. By the end of this video, you'll understand how counting a few rings can help predict the future of our fisheries and why this method is so important for sustainable fishing. So, stay with me because once you learn this, you'll never look at a fish the same way again. Narration generated using AI for educational purposes.
Hi everyone, I am Dr. Vicky John. Today we are going to talk on something very interesting. Do you know, most people eat fish without knowing the secret that is hidden behind the scales of this fish. So for that reason, we are going to talk about the age determination of fish stock. The age determination of fish stock can be used to tell the age, the size, the structure, the optimal growth of this particular fish. How long have they been in existence? You eat fishes every day and you throw away the scale. Have you taken time to look at how the structure of that scale looks like? Also, you can determine the age of a fish stock using the scale. You can also determine the age of the fish stock using the otoliths. What are these otoliths? The otoliths are the ear bones. They are the ear bones and they are used to calculate how old have these fishes or fish been in existence. It gives statistical information on the structure and the age, the growth rate of a particular fish within its population. So we are going to assume a calculation now. So in age determination of fish stock, assuming we can be given an issue like this to provide a solution. Assuming you have a data set of 20 fish sampled from a freshwater body that is located in Port Harcourt and age using Annuli counts. Annuli counts are those rings on the scales of that particular fish. Now, the ages obtained in years were as followed. These are the numbers of the ages, the ring that were found on the scales. Now, you're being asked to prepare an age frequency distribution table for the fish sample. The B part of it, you're asked to calculate the relative frequency and also the cumulative frequency curve or frequency for each age class. Then the next one, you're asked to draw a bar chart. This bar chart now is to help you represent the age frequency distribution. The D part of it, you're asked to draw a cumulative frequency curve, which is an Ogive for the age data set. Then the E part of it, you're asked to determine the median age of the fish population using the Ogive graph. Now the fifth one, the F part of it, briefly comment on the age structure and what it suggests about the fish stock status. If you are being given a problem like this, first of all, you have to look for the number of occurrence within the scales of these fishes. That's the ring. So you prepare an age frequency distribution table for the sample, which is A. Okay, and for you to prepare the age frequency distribution, you will need to do it in a tabular form. This is the age frequency so that's it. Okay, you have the age, the frequency, the relative frequency, the cumulative frequency. This is F divided by the total number. Okay, so now from the age, we have ages of 1, 2, 3, 4, and what? 5. So you write it here. 1, 2, 3, 4, 5. These are the ages. Then for the frequency, frequency has to do with the number of occurrence. If you check from here, 1 we have 1, 2, 3, 4. We have 4 of 1. 2 we have 1, 2, 3, 4, 5, 6, 7, 8. 8 of this. 3 we have 1, 2, 3, 4, 5. 5 of 3. 4 we have 2 and 1. Now, for you to get your relative frequency, it has to do with the relative frequency divided by the n. What is the n? The n is the total number of frequency that appeared. You have 4 plus 8 will give you 12. 12 plus 5 will give you 17. 17 plus 2 will give you 19 plus 1, 20. Okay? Then, for the relative frequency, you have to say 4 divided by n. 4 divided by n will give you 0.2. So you have to round it up to 2 significant figure. Then 8 divided by 20, it will give you 0.40. The next one, 5 divided by 20, it will give you 0.25. 2 divided by 20, it will give you 0.10. 1 divided by 20, it will give you 0.05. This is it. Then now for the cumulative frequency, you need to add it with the lower frequency occurrence. This is 4. 4 plus, that's the CF. 4 plus 8 will give you 12. 12 plus 5 will give you 17. 17 plus 2 will give you 19. 19 plus 1 will give you what? 20. So these are it is. These are it is for the relative frequency. Then, mind you, the least cumulative frequency must be equal to, it must be equal to the total frequency that occurs. If you, after calculating, if you notice it's not the same, please, you can equally cross-check. So the next question on our list is to calculate the, okay, we've calculated the relative frequency and cumulative frequency for each age class, which is this, and the cumulative for each age class. The next one is to draw, the C is to draw a bar chart. Draw a bar chart to represent the age frequency distribution. How do we draw a bar chart? In here we have what? we have both B B here, which is relative frequency. But if you want to do it too, you can still as well look for the age frequency distribution, which is age and the frequency first. Then the next one, you now have another table that can give you the age, the frequency, the relative frequency, and the cumulative frequency. So we have to join them together to solve. The C part of it, you are going to draw a bar chart to represent the age frequency distribution. Okay. So this is a bar chart of age frequency distribution. This is the x-axis, which represent the age, fish age, or the years of the fish. Then this is the y-axis. It represents the frequency. Okay. Then now the age for the x-axis, we have 1, 2, 3, 4, 5. Then for here, the frequency, the highest is 8. So you can take 1, 2, 3, 4, 5, 6, 7, 8. So for age 1 is 4, the number of occurrence. For age 2 is 8. For age 3 is 5. For age 4 is 2. Age 5 is 1. If you check, the dominant frequency of the distribution of fishes within this is what? 2. This is the dominant, okay? This is the dominant. So this indicates that height of each fish scale in each bars represents the age of the fish based on their classes. Okay, so if you check in this bar chart of the frequency age distribution, you notice that the highest height, the higher height falls within age 2. This indicates dominance in the smaller fish age, which is age 2. That is to say that there is dominance in this age 2 fish distribution of its wing than the other ones. If you check these other ones that the ages are higher, they have lower fewer frequency within the distribution of this sample. There is a dominance in this fish age of 2. Okay, so we are going to look at the next one to draw the cumulative frequency curve for the age data. For you to draw the cumulative frequency curve, which is So here, your x-axis is still your age. Then your y-axis is your cumulative frequency. Okay? Is your cumulative frequency. So the age, 1, 2, 3, and here you have 5. So when you check your cumulative frequency, the least is 4, and this other one is 20. So we can take 2 cm. So what we have to do is to plot it. For your cumulative frequency, age 1 will give you 4. Age 2 will give you 12. Age 3 will give you 17. This is age 3. This is you need a graph for this. Then age 4 will give you 19. 19 is somewhere here. Then age 5 will give you, I hope I have this is okay. Then age 5 will give you 20. So you can trace it. So this is how the Ogive curve should be. Okay, on a straight line. If you're using a graph, it should be better than this. And mind you, an Ogive curve is not supposed to go downward. It's supposed to face what? Upward. So the next one, which is E, is to determine the median age of the what? Fish population using the Ogive. Is to determine the median age of the population using the Ogive. Now, for you to determine the median age of the population using the Ogive, you can check. We have total number of fish population or fish frequency within the population as what? 20. So for you to calculate your median n divide by what? 2. So if the total number of fish frequency within the population is what? 20. So 20 divided by 2 will give you what? 10. That means the median falls between what? 10. You can still go to your graph. This is the median. So this is your median. So the median is what? X and Y and what? X, which is 2. That's your median. Okay? So this is your median. If you're asked to look for the median, yes, it falls in between what? It falls as 10 based on the total number of fish frequency divided by 2, which is n divided by 2, 20 divided by 2, giving you 10. You go to your cumulative frequency curve, you look for where 10 falls, and which of the age does this 10 fall into? The age 10 falls into is at what? Age 2. That is it for the median. The next one is to briefly comment on the age structure and what it suggests about the fish stock. To comment on the age structure of this fish and status or the stock, what you need to do is that, looking at this axis now, from the age of 1 to 5, you will notice that age 1, 2, 3 have higher proportion of younger fishes. And now in age 4 and 5, you see that they have relatively few older individual, which in their ages, you can see that they have what? Few older what? Individual. Now, what does this tell? This suggests that the fish population is young. This suggests that the fish population is young dominated. Okay? The fish population is young dominated, which may indicate high recruitment into the stock. It may also indicate possible fishing pressure, removing the older what? Fishes. Now, a stock that is more productive but potentially vulnerable if exploitation continues unchecked. If exploitation now is not checked, what happens? If exploitation is not properly checked, what happens? You notice that these older fishes will be vulnerable. You won't really get older fishes within this particular aquatic ecosystem. Rather, you have more of smaller fishes. So, this assessment helps fisheries management to be able to manage fish data within that particular environment. Thanks.